and good day. We are back with geometry in now CO4, applying the distance formula in various contexts. So we are going to go back to our segment that we had at the beginning of CO3. In CO3, we were looking at where the midpoint of this segment was, and we found that we could either use the formula or, given a coordinate plane, it wasn't too difficult to find it. We could use slope to find it. We can look and see where it falls, as long as we're sure to check ourselves afterwards there. But if I ask you how long this segment is, that's a little bit of a different ball game, right? It's easy to tell me how long a horizontal segment is. You know, it's pretty clear that's 3 units. It's easy to tell how long a vertical segment is. Pretty easy to tell that's 5 units there, right? But once you get to diagonal segments, I mean, going across diagonally, every time that you move over a square, it's not a value of 1 unit, right? That's why the hypotenuse or the diagonal side of a right triangle is always the longest side, right? Because you have the vertical, you have the horizontal, and this diagonal side is always the longest, even though it goes the same vertical distance and same horizontal distance overall. It takes longer to get there when you go diagonally, right? That's kind of the Pythagorean theorem background I was asking about earlier. So instead, we have what's called the distance formula. And you know that this is going to be a good formula when I start drawing it like this. Look at that root sign, huh? This is going to be fun, okay? It wouldn't be fair to not define distance. What is distance?
How far away from points are?
Yeah, okay, sure. Yeah, it's the length of a segment. We don't need to overcomplicate it. That's what we're finding today. This distance formula is used to find the length of a segment. Again, particularly if you don't have a coordinate plane, you're just given 2 points, the endpoints of the segment. You can use this to see how long it is. And the formula looks like this. It is the difference of your x values. So x1 minus x2. That difference is squared. And then we're adding to that y1 minus y2, the difference of your y values, squared. I made my root sign a little bit too long there. I'll bring it back. Okay? And then it's the root of that sum. So order of operations indeed in play here. But it's the difference of your x values squared plus the difference of your y values squared and the root of that whole thing. Yay! Okay. All right. So let's go back to our segment here. And I'll write the formula up here again. D distance equals x1 minus x2 squared plus y1 minus y2 squared. Okay. And so we've got our endpoints here, again, of -4, -3. And the other endpoint is at 2, 1. And I'm again going to label x1, y1, first x, first y, second x, whoops, and second y. And here we go, okay? The square root of our x values, -4 minus 2, that's being squared, plus the difference of our y values, -3 minus 1, and that's being squared. Ellen? If you could do all of this in your head, Ellen, then you should be up here. Yes, work should be shown. I mean, maybe not necessarily every single step, but I'll be very suspicious if all I saw was just an answer and that was it. Okay, so -4 minus 2 is a -6 squared plus -3 minus 1 is negative 4 squared. Negative 6 squared is, negative 6 times itself is, well, it's negative 6, and that negative sign being in the parentheses with it means you're taking negative 6 times negative 6. So a negative times a negative is going to be a positive. And then negative 4 squared, negative 4 times negative 4, 16. We add what's inside the root, and we get the square root of 52. Okay? I would like you to leave your answer in root form. If you were actually going to Home Depot to buy root 52 length of fencing for your yard or something, you would not say, can I have root 52 feet of fencing? You would get the decimal value of it, which based on what we did in CO2, we know is approximately what?
According to the calculator, it's approximately 7.2.
Approximately 7.2, right? Root 49 would be exactly 7, that perfect square, and root 52 is a little bit more than that, so it'll be a little bit more than the 7. We get about 7.2. Okay, but I do want you to leave your answers in root form, unless otherwise stated. And that's the distance formula. Ta-da! Okay, let's go back to our page. Which one of these three would you like to do together? Lucas?
We did the middle one?
The middle one, why not? Lots of negative signs there. So we have endpoints A and B, 10, negative 11. I'm going to label that x1, y1. And negative 6, negative 20, x2, y2. And use the distance formula, okay? And here we see a situation where we do indeed subtract a negative number, right? x1 minus x2. x1 is 10. The subtraction sign's got to be there because it's part of the formula. And then our value for x2 is negative 6. So again, correlating beautifully with what we did in PO3, when would I ever subtract a negative number? Well, here's a situation. When you have a formula with a subtraction sign, and you're plugging in a negative value, this will end up being 10 plus 6. And then y2 minus y1, we've got negative 11 minus negative 20. Another minus negative here. And then we are squaring that. So 10 minus negative 6 is positive 16 squared, plus, why can't I just make my root long enough? My goodness. Oh. Plus negative 11 minus negative 20, or negative 11 plus 20, is 9, and we're squaring that. With this much of a multi-step situation here, the multi-formula, raise your hand if I've lost, or if you have a question. If I've lost you at this point, or you just want to clarify something, yeah, go ahead. Please, yeah, for sure, yeah. This is not testing your computation skills. You know, I mean, the tool's there. Yes.
When we're doing this, if a number can safely be square rooted, do you want us to square root it or just keep it?
If you get a perfect square as an answer, then yes, you can simplify it or take the root of it. So, okay, so 16 squared is 256. 9 squared is 81. And so the length of this segment, you would add 256 and 81, and I believe we get 337. Is that what people are getting?
Yeah.
Okay. Good. Other questions? Okay. So your homework is to practice this with the other two. Okay, the first and the third one there. And then the real world situation here says, take a look at the landmarks you built in your town in CO3. So back to CO3, I think they look something like let's see, we had one here, one here, one over here, and one up here somewhere. Is that about right?
Yeah.
Okay. So as mayor of this town, it is your job to construct sidewalks that will connect all 4 buildings in a quadrilateral. What's a quadrilateral? Four-sided shape. So your sidewalks are connecting these towns to make a 4-sided shape. So it should look like this. Okay. Trapezoidish looking thing, not quite that, but if each unit of sidewalk costs $65, how much of the town's budget will you be spending on sidewalks? Okay. So whereas in CO3 you had to use the midpoint formula to find the midpoint between each of these things, now I want you to find the distance between each point, and then calculate how much it's going to cost you for sidewalk. And you have till Wednesday, so okay. So which 2 would you like to do, or which 2 points would you like to find the distance between together? You'll have to help me with what the ordered pairs are, but go ahead. Yeah.
The library and city hall.
Library and City Hall. Was that this one and this one? Okay. What's the ordered pair of the library? 3, 6. And what's the ordered pair of City Hall? 5, -4. Okay. So we'll find the distance between 3, 6, and 5, -4. We've got our x1, y1, x2, y2. Using our formula, we're going to take the difference of our x values, so 3 minus 5, square that. I like the way the green pen writes better than the red. I might go to this one. This is nice. And then the difference of our y's, 6 and -4. So 6 minus -4, and we're squaring that. Just for starters, just plug in the values, right? Now doing some algebra. 3 minus 5 is -2. We square that. 6 minus -4 is 10. And we're going to square that. Right? So -2 squared, -2 times -2 is +4. And then 10 squared, 10 times 10 is 100. And so the distance between the library and the city hall is the root of 104. Okay? So in this context, in this situation, what makes more sense? Our answer as a root or get the decimal value?
Decimal value.
Why is that?
Because if you're talking about, like what you said earlier, if you're going to get a certain amount of money or a certain amount of an object, and be like, hey, I need the square of blah, blah, blah number, you would have to square root it and find like the closest decimal.
Right. So, yeah, no question?
Yeah, so if it's -2 squared, wouldn't that be -4, not positive?
So these parentheses are very important here, right? In the formula, notice how we've got parentheses around our subtraction and the powers on the outside. What that is telling us is that we have to take whatever is inside the parentheses and square it. So -2 in parentheses squared literally means -2 times itself, or -2 times -2, which is +4. Now, your calculator, this is where good to talk about this here. Your calculator does exactly what you tell it to do. It's a machine. It's a computer, right? So if you type in -2 squared and you're wondering why you get -4, it's because you didn't tell your calculator to do this. Your calculator, following the order of operations correctly, will square 2, which is 4, and then just put the negative sign on afterward, because this exponent comes first. Okay? So whenever you square a negative number, if you're using your calculator, make sure you put it in parentheses, because if you notice, if you put -2 in parentheses and then square it, you will get +4. Okay? That's why I even put parentheses around my +10 here, even though they're not necessary, just to remind myself that it's what's in the parentheses that I'm squaring. 10 times 10, -2 times -2. Okay? So anyway, root 104 is approximately what? How would you estimate that? What would you say? Yeah. 10.2. Okay? So we need 10.2 units of sidewalk to get from the library to the city hall. If each unit is $65, how much is it going to cost us for sidewalk for that section? How would you find that, Audrey? Yep, 10.2 times 65. Okay, which is going to be 670 something or something like that. 663. Okay, so it'll cost about 663 for this section. Now you've got to go figure out from the school to the library and the church to the school and the church to city hall and add them all together for the total cost. Yes?
Does it matter, like if it was the library to the city hall, and you did three 6 as your first coordinates, would it matter if you switched it around?
Great question. So she's asking, we label these X1, Y1, X2, Y2, but what if I had written City Hall first? So that was my X1, Y1, and my library second. So that was my X2, Y2. If we did that, and I'll spare you all the grunt work here, but if we did that, what we would get is just these numbers here and these numbers here reversed. So we would get the difference of, instead of 3 minus 5, 5 minus 3 squared. And instead of 6 minus -4, we would get -4 minus 6, right? And the beauty of the distance formula is that 5 minus 3 is +2. What do we get when we square +2? 4, the same thing we got when we squared -2. Here, -4 minus 6 gives us -10. What do we get when we square -10? 100. The same thing we got when we squared +10. So the beauty of taking the difference and then squaring it is that you'll always get the same result regardless of which ordered pair is listed first. Math is beautiful. It's like they thought of everything. Okay? All right. I don't know about you, but that's a lot of formulas and X1s and X2s and Y1s and Y2s. So I think it's safe to call it here. If you want to take off, feel free. We've got about 5 minutes left until it's officially done. If you want to stay and work and ask questions and make sure you're on the right track, that's fine too. But homework for Wednesday is the rest of CO3 and the rest of CO4. You've got 2 to do up here, just kind of practicing the formula, and then your town and the sidewalk cost. And that, folks, is how you math.
Don't forget to like and